So let's start. So before we start, this is a time which is concerning for all of us in this region. The coronavirus infection rates are extremely high and we are all in panic situation. But what we like to share is that by following these simple measures, we can control the virus, we can be safe. Safety of our family, safety of our colleagues, safety of ourselves is utmost priority. So we at Fisher, we recommend you these small guidelines recommended by WHO. Please use an alcohol-based sanitizer or wash hands as often as you could. Your mouth and nose when you sneeze or cough and wash it properly. Avoid touching your eyes, nose, and mouth with unwashed hands or unclean hands. Uh, I make it a thumb rule that I don't touch my face if I don't use a sanitizer or I wash my hands. Do not use clothes and utensils used by somebody you expect them to be like they're not well. If you are not feeling well, please seek immediate medical attention. So I hope all of us remain safe, all of our families remain safe, and we can continue working together healthy and more effective way. Thank you very much. I would like to introduce myself. My name is Tino Thomas. I work as Technical Manager UAE in Fisher. My user ID using which I would be interacting with you would be Fisher MEA. If you have any technical issues, either Fisher support team or Marsu KP would be there to assist you. So the moment you have any concerns regarding your connection, streaming, if the webinar is not loading or such technical glitches, Marsu KP, that's the username who would support you on such issues. Today's time split would be as follows. We would have the webinar till 11:45 a.m. There would be a question and answer session in the last 10 minutes, followed by a poll session for 5 minutes. So we kindly recommend all of you to please take your time to complete the poll and give us a feedback before you leave the session. These are some tips for a better webinar experiences. So please try to use Google Chrome or Firefox, preferred Google Chrome because you will have much seamless experience. Try not to use Internet Explorer because in the past we have had problems with Internet Explorer during the webinar. Please do not do parallel downloads. Why? Because if you do a parallel download, it might affect the connection speed, which might make the streaming slower. All your questions will be answered at the end. But please make sure that you post your questions in the questions tab. All answers would be mailed to all of you so that you won't miss any part of it. So I hope you are having a screen like what you can see now. So the first thing is to make it full screen. There is a full screen option as you can see here at that part of your screen. So make it full screen. Then you have a chat screen. I'm sure all of you know because I can see a lot of chats pouring in on this chat screen. So I'm so happy for that. Then we have questions tab. Now this is the trick. If you put your questions in your chat tab, after many chats, your questions might get lost and maybe I won't see these questions. So I strongly recommend if you have any questions, please go to the questions tab, record your questions, and then we would make sure that you would get a reply to those questions. Polls. Polls is for us to get your feedback. So it is very important for us. So to the poll screen and rate your polls there. So this is useful for us to improve our webinar services next time. Thank you. So Now, let's start with a question so everyone gets energized. What is seismic force? What, in your opinion, is a seismic force? Okay, I'm still waiting. Okay, thank you, Mr. Ihab. So, Ihab says it is a lateral force due to earthquakes. I agree. What else? What is causing seismic force? Any guess? Okay, brilliant. So, seismic is the irregular movement of different layers of Earth. As you know, Earth has got different layers. So, when there is an irregular movement, then it creates certain pattern of forces which is called seismic. So, seismic can become really fatal at some times. We have seen several accidents in the past, like the ones in Indonesia, the ones in Nepal recently. So it can go out of control. It can cause a national calamity. It can cause a sense of emergency situation if it is not designed properly. So there are additional forces applied to the structure because of earthquake or because of seismic forces. So if the building, if not designed for these additional forces, then the building might collapse, depends on the intensity of the earthquake. Why do you think building needs to be designed for seismic forces? Or why is a seismic design required? Thank you, Mr. Haider, for replying to the previous question. Thank you, Mr. Taufik. Taufik says we need to maintain safety during earthquakes. Sorry, Taufik says not to get damaged, and Khalid says we need to maintain safety during earthquake, save lives. Okay, brilliant. Anything else? So one is safety. Safety for what? Is it for building or for life? Life. Okay, both. Okay, for all. Yes, brilliant. I can see that there are three guys who are very interactive, very energetic, but I would also urge rest of you also to participate more so that we can have more fun, more interaction. So yes, all of you are right. The first things first, seismic design is important because it is a protection for human life. In the event of an earthquake, our, ourselves and our fellow human beings are protected. There is no damage for life. This is top priority. Damage is limited. If you have a building designed for seismic, we are limiting the damage in total. Structures which are important for civil protection remain operational. Like, for example, a hospital. Imagine a scenario where there is a seismic activity, an earthquake, and all the hospitals collapsed. Where would we treat ourselves? Where would we treat the injured, the patients? So it is very important that those important structures, like where it is mandatory shelter, like hospitals and police stations, such important buildings needs to be withstanding the effect of seismic. Seismic control can be done in two levels. The first level is a no collapse requirement. What does it mean? It means that with the seismic force, the seismic design should withstand seismic action without collapse, which means imagine there's a building, the building should not collapse even after subjected to an earthquake. Also, it should retain its structural integrity and load capacity. For example, you have a 20-story building. That 20-story building should maintain its structural capabilities even after subjected to an earthquake. So no failure of the building does not collapse. This is level 1, no collapse requirement. By the way, this is as per Eurocode 8. The second requirement, which is on a higher level, is damage limitation requirement. So what does it mean? It means that you should withstand strong seismic action without damages. So for example, all the components or the main important components inside the building, like for example your ceiling, imagine it's a heavy false ceiling and it falls on top of you, or a chilled water pipe falls on top of you. So such things should not happen, which means the building should be safe, as well as the there are certain applications which also need not should not fall in the event of a earthquake. Also, in damage limitation requirement, the building should not be limited for use after the earthquake, which means if I'm in a building which is designed for damage limitation requirement, I should continue to use this building even after an earthquake without any repair or without any maintenance, which means this building is designed with all its components to withstand a seismic activity. So you can continue this usage of the building even after the earthquake. Now, what do we offer as Fisher? We offer seismic anchors, normal or seismic supports for MEP, including seismic anchors. We also provide calculations. Any questions so far? Okay, please, if you have any questions, go back to the questions tab and record your questions. Okay, now let's talk about the main component, which is the building structure itself. So as we know, there are some changes happening to the building structure during the earthquake. And as most of you rightly explained, seismic is a lateral movement of the Earth's layers. So you have horizontal movements rather than vertical movements. So the whole building would be subjected to horizontal movements. So here are some main differences between static and seismic design with respect to concrete. So let's say in a static design, let's say we have an application, let's say fixing of an equipment. On a normal static load, there is no cyclic load or very small cyclic load which could act in normal static conditions. In a seismic design or a seismic condition, the loads might have huge cycling action because the earthquake is pushing the application to all lateral dimensions. So this is one main difference. Another main difference is in the structure itself. So in a normal static environment, the structure would have cracks only on the tensile zones. So wherever you have tension in concrete, that area are likely to develop cracks. As you can see, the red color lines show cracks happening at that part of the structure. In a seismic, cracks can occur anywhere because of building movement in all directions. Another difference is normally the allowed crack width should be limited to 0.3 mm under the service condition of the building. In a seismic environment, what do you think? What shall be the crack width? What shall be the crack width allowed or expected in buildings designed for seismic? Point 0.3, 0.8, okay, great. 0.5, Okay, great. As per European standards, the crack width can be wider up to zero point 0.8 during seismic according to European Technical Authority guidelines. So if you have the anchors installing an application, then those anchors should be tested for crack widths up to zero point 0.8 mm. Another difference between static and seismic. In static loads, the cracks develop when there is a load and closes slightly when the load is going away. Like when you have a moving load or a live load, the cracks may develop when there is tension developed at that part of the concrete, and then it closes when the load is moving away. Mr. Khalid, these are as per European Technical Authority guidelines for, so it is basically as per Eurocode standards. The seismic anchors, the concrete can be up to 0.8 mm in the event of a seismic. So differences between static and dynamic in terms of crack. In terms of seismic, you have cracks opens and closes widely, and it can be almost in any surface. So here is a building structure with some loads, with some applications. Let's say you have a pipe, you have some other applications. So there is a ground acceleration because of earthquake. Also, there is acceleration at the floors. So imagine if we have a building of 1 to 4 floors, floor 1 to floor 4. Where do you think the peak seismic force would be? Is it on floor 1 or floor 4? Of course, you are right. It makes sense, right? So the maximum seismic force would be acting at floor 4. Now we would see a small video which is about seismic anchors. Was the video clear? Okay. I can see that for some of you the video was not clear because I got feedback also from some of my colleagues. It was not, probably it is the problem of streaming. So I would arrange to send a link for this video to all of you. So maybe after the webinar, you can continue watching it. So we don't want to spoil your experience, so we would share it to each one of you. Thank you. Now, the code for design of seismic anchors is based on European Technical Authority Technical Report 045. This is the code if you need to design an anchor for seismic forces. So basically, we calculate the loading as per Euro codes or EN 1998. The resistance is calculated based on TR45. So TR45 says how to calculate the anchor capacity, to calculate the effect, and how the anchors are safe or not safe when there is a seismic activity. So basically, it all goes down to applications. So as you can see, this is an example of a building structure. You can see 4 applications here. Application number 1 is the least critical application, which is non-structural components like rooftop mechanical units, water heaters, shelves, modular partitions, computer components, switch cabinets, emergency power systems, etc. Become hazardous to life when they slide, break, or fall during an earthquake. They may injure occupants or block exits from the room or building. So this is general equipment. The second application is HVAC applications, HVAC application. Like here, the correct anchoring and bracing of non-structural components and systems is crucial in structures intended to handle the emergency so that these services can continue even after an earthquake. For example, your chill water pipes or firefighting pipes. It has been studied that when you have an earthquake activity, you have more probability of the building catching fire. So in the event of an earthquake, also the firefighting pipes should work fine. So all these falls under type 2 application. Then you have application number 3, which is structural strengthening. So it is for strengthening the building itself. Imagine it was an old building and it was strengthened, or it was not designed for seismic, now it is strengthened or whatever. So basically it is strengthening of RC structures with steel bracing systems or reinforced concrete bracings. The bracings are usually placed in vertically aligned spans and allows to an increased stiffness with a minimum added weight. So basically, this structure is providing additional stiffness to the building so that when you have an earthquake, it is more stronger. And also, last but not least, is the facade. Earthquake may damage facade systems undoubtedly, poses a large threat to life. Subframes and brackets for curtain wall applications must be anchored safe to the structure to ensure a proper load transfer of dead loads and horizontal loads caused by live loads and seismic forces. So if the whole building is seismic, also the facade also should not be omitted. It is also a high risk area where you have a whole facade. Imagine if it fails, if the anchor fails, then the whole facade can collapse. So which is also a critical aspect. Now, for every project, you have to put this project in an importance class. So importance class is a class given to the project based on its use. So importance class number 1 are buildings and structures that normally are subject to human occupancy, such as storage sheds, not subjected to human occupancy. So this is the least importance class where you have chance for less people staying in this building. So they do not contain equipment or systems necessary for disaster response or hazardous material. So it is very important that importance 1, because there is less human occupancy. Also, you have to take care that there is no hazardous materials like chemical storage warehouses or disaster response system should not be in this building. Second is importance class 2. Most buildings and structure for ordinary occupancy, such as residential buildings, commercial buildings, industrial buildings, So these falls under importance class 3. So a normal residential building falls under importance class 3. Now again, this is as per European standards. As per American standards also there are different categories. Importance class 3, building and structures that have large number of occupants, such as high-rise office buildings, sports arenas, theaters, or shelter persons with limited mobility, such as jail, schools, healthcare facilities, support lifelines and utilities important to a community's welfare, or contain materials that pose some risk to the public if released. So also in importance class 3 comes dangerous goods. Storage of dangerous goods falls under importance class 3. Importance class 4, the highest of it all, are buildings and structures that are essential to post-earthquake response, such as hospitals, police stations, fire stations, emergency communication centers, or house very large quantities of hazardous material. So all these, for example, nuclear storage falls under class 4. Hospitals, police stations, all of it falls under class 4. So this is the peak. So it means that if you have class 4, which means this building should work the way it is even after earthquake. So it should be designed to overcome the effect of a possible earthquake estimated. So to design of anchors as per TR 45, you require basically qualification of anchors. There are certain standards such as ETAC 001 Annex E, which qualifies for mechanical anchors. There are also ACI guidelines, which calls for requirements of anchors to qualify for seismic applications. One important qualification is any anchor can be a seismic anchor only if it is designed for work in cracked concrete, which means non-cracked concrete anchors are normally not qualified for seismic purpose. Another requirement is the approvals. The anchors should have a valid ETA approval or an ICC approval. If you're following ACI standards, the anchors must have an ICC approval, International Code Council approval. If you're following European standards, it should have European Technical Assessment document. So this is mandatory. Design documents. You can design seismic anchors as per ACI 318 if you are going with the American standard, ACI 349. You have UBC and IBC. You have, if you have following the European standards, you can choose EOTA TR 45, which is widely accepted around the world for seismic design of anchors, because most of the anchors, I would say 95% of the anchors carry ETA approval. So automatically it would be referred to as TR 45. Or you can design as per Eurocode 1992. Now, in the approval, the ETA approval or the ICC approval, also you must have seismic performance included. So some anchors are approved as per ETA or ICC, but seismic performance might not be available. In this case, we cannot design these anchors for seismic performance. So while we design the anchors, as you know, there are different failures that can happen to anchors, such as steel failure, pull-out failure, concrete failure, etc. The most common failure is the steel failure, especially in shear loads, because you would have a sense of fatigue on the anchors because you have moments around the lateral direction. So the steel is more likely to fail than concrete itself. So these are the checks which we need to do to ensure that the anchors are safe or not safe. For example, we have to check the steel failure capacity, pull-out failure capacity, combined pull-out and concrete failure capacity, concrete capacity, splitting of concrete capacity. Again, in shear loads, steel failure, concrete edge failure, concrete pry-out. So these are checks normally we do for static load also, but in seismic, we have to again evaluate its performance against seismic reports, seismic evaluation reports, how they behave in the event of an earthquake. Also, there's a difference or reduction factor. For example, performance of a single anchor is 1. In steel, it is same for anchor group. Anchor group means you have more than one anchor in your base plate. So some cases, for example, concrete cone failure, you have one as for single anchor, and if you have a group of anchor, you should have a reduction factor of 15% or multiply this with 0.85. Same thing in shear. In steel failure, if you have a single anchor, you can take the full seismic capacity. But if you are using, let's say, 4 anchors, then you cannot take the full steel capacity. You should multiply the capacity with a reduction factor of 0.85 to stimulate a conservative approach. As per ETAG 001 NXC, where it qualifies for mechanical anchors, normally the maximum crack width is 0.5 while we do the test for static anchors. You are supposed to do 1000 crack cycles with a crack width of 0.3 and limited cycles with a crack width of 0.5. This is for static. Now, what about seismic? When you have seismic, there are two categories. Category 1 is the level 1, which is less critical. Here, we need to do 140 load cycles in tension in a crack width of 0.5 mm and 140 load cycles in shear with a crack width of 0.5 mm. Category C2 is more critical. Here what happens is the crack width shall be up to 0.8 mm, 75 load cycles tension, 75 load cycles in shear, and 55 load cycles in various crack cycles. So this is a more elaborated and a more critical testing procedure which we have to follow. So always you would find anchors with C1, but C2 is you have limited numbers. In Fischer, we have a huge range of products, mechanical anchors, which fall under category, which are tested under C1 and C2 categories. So this is again a summary of tests which we have covered. So in C1, you have tension load and shear load. You have minimum number of tests at 5 numbers at a crack width, which is maximum of 0.5. And C2, you have 0.8 as your maximum crack width. So the performance after the test is done are all recorded in the approval document. For example, in the European Technical Assessment document, you would see the tensile seismic capacity. For example, for M16 anchor, it is 76 kilonewton in tension. Also, you have this is C1 and this is C2. So you can see the difference. C1 is 76 and C2 is 12.8. Also, in shear loads, you would find the performance evaluation. For example, for M16, the shear capacity is 41.3 kilonewton. So another important factor which we need to consider while we design anchors is how the anchors are fixed to the base plate. For example, if you have a gap between the anchor and the base plate, for example, your anchor is 12 mm and your base plate hole is 14 mm, which means there is a 2 mm gap. So then your capacity need to be reduced by half or multiplied by 0.5. Whereas if there is no clearance, for example, this 2 mm gap, is it sealed with a non-string grout which can limit the hole clearance, then you can consider the same capacity. This is an example. Let's say we have an anchor with a seismic performance of 13.4 kilonewton in tension. 13.4 is the seismic capacity in tension. When we have a hole with gap, the capacity is calculated like 0.5 into 0.85. Why 0.85? Because we are calculating a group of anchors. So 0.5 into 0.85 into the seismic capacity mentioned in the approval. So your group capacity is 5.3, sorry, the single anchor capacity is 5.336, and the shear capacity is 14.28, but actual capacity as per the approval is 33.6 kilonewton. Same thing applies when you have group with two anchors without gap. So you see, instead of zero point 0.5, it became 1 kilonewton. Sorry, one safety factor, one reduction factor, or there is no reduction. So if you need a design support to bear seismic loads for your MEP supports, we undertake design seismic designs, as well as we provide seismic design supports from Fisher. So let's skip to the MEP part. What do you think are the effect of seismic on MEP services? What happens on MEP services, suspended pipes, suspended ducts, for example? How does it affect seismic? Like, what is the effect of seismic on them? Hello? It could fall off. Brilliant, Mohammed. Any other response? Any other factor which we need to consider? It could hit people. Exactly. It will disturb the purpose. Yes. There could be leakage. So all of you are right. It could block corridors and hinder the escape route of people. This is top priority because it is safety for people. The second is, during an earthquake, normally the fire burns out. So if, for example, your chill water pipe sways and hits on your firefighting pipe, and the firefighting pipe breaks, as you said, so the firefighting pipe is not functional anymore. So a threat to life. The contents of the pipe may be fatal. So, for example, in hospitals or industrial environment, there could be nitrogen pipes. There could be hot water for your heaters. So all this, imagine if it falls down, it could be chaos. So this is also very important for us to consider. And last but not least, huge loss of properties. Imagine you have a building, the structure withstood seismic, but the whole MEP package has been damaged. Imagine the cost you need to spend to renew all of these services. So this is also a top priority. So we do seismic design based on different codes such as UBC, IBC, local codes such as the seismic design code for Dubai. Also, there is Saudi building code. Also, if you have local building regulations for seismic in your countries like Oman, like Kuwait, also we can study those and we can provide you an app design recommendation. So for seismic restraint system or seismic for MEP, we need to know certain parameters for design, such as the soil type, what is the building height, MEP service type, project importance category, and so on, and then location. So based on this, we calculate the horizontal force which is acting on the MEP. So normally, the seismic force is a ratio of the weight of the dead weight or the service weight of the application. For example, you have a pipe which is 100 kg per meter, let's say, as an example. Your seismic force is normally a ratio of this 100. Let's take, upon calculation, we came to know that the seismic ratio is 0.3, which means that there is a 30 kilogram seismic load on this particular pipe. What are Fischer solutions for MEP? Number one is a seismic rigid system, so wherein we give channels. This is a brilliant system when you are at an advanced stage, which means you are considering seismic before the building is the application has been installed. It is also a beautiful system when you have space congested locations such as corridors. Imagine a hospital. Wow. How many MEP services would be passing? How many false ceiling suspensions would be passing through a corridor? So there you have a space limitation. So this is an ideal system, a rigid system. Secondly, we have a rigid system with channel bracing. So this is also suitable for congested areas with high seismic loads. Then we have a wire bracing system or a threaded rod bracing system. So this is beautiful system. Imagine I've seen somebody ask me a question: if you have already completed the work in a building, can you convert it to seismic? This is the solution. You can convert an already existing MEP service to a seismic support by adding certain bracings. But here the challenge is you need space for accommodating the bracings. So the rigid system looks like this. Upon seismic analysis, we come to know what is the spacing between two seismic supports. So, and then we provide the rigid system. As you can see here, it is a rigid system for a cable tray. As you can see on the bottom right side, a close-up or a blowout image. So in this case, the seismic support needs to be installed same time while you are installing the normal support. Channel bracing system. This is again how it looks like. You would have a defined frequency. We would recommend you this frequency between seismic services. These are some real world images again for seismic supports. As you can see, there is a cable tray supported with rigid bracing. This is also useful when you have huge drops, like more than 1 meter drop. Then the channel is too long, the vertical member is too long, so you would be having a requirement for bracing. This also needs to be installed. You can install later on also, but it is normally recommended that you do at the initial stage, so it's more easier. A wire or threaded rod bracing system. So this is how it looks like. You can convert a normal system, suspended system, to a seismic system with the help of certain bracings. This is how it looks like. A normal threaded rod support for a cable tray can be converted to seismic support by arresting the seismic forces on both sides or on 4 directions using these wires. Also, you can use threaded rods. We have a special system which can provide bracings using threaded rods. Mr. Abdul, we have special accessories for connecting. As you can see, this is a special connection. We have these accessories. We can share with you the details of these accessories to connect the rigid system to the bracing, the channel bracing, how to connect this connection. We can share with you the detail. There are accessories which can do connections. So this is how a wire or threaded rod bracing looks like. Here, the beauty is you can modify your existing support. For example, this was a normal cable tray support with threaded rods. Now there is seismic requirement. You can easily convert it. Okay, so let's see an image of how a firefighting pipe is supported with seismic bracings. I have a better image also. Now here you have 2 videos. One is before and after. We would first see before, which is before a seismic bracing. So you can see the duct is installed, cable trays are installed, and now somebody is shaking the whole support, and you see the supports are moving. Okay, now we will see after installing a bracing. So you see he's trying to move, but the support does not move because it is braced. I will play this again. So that is how the bracing system works. So this was an actual mock-up done in North Depot for FAST Consortium in Saudi Arabia for Riyadh Metro. Yes, Mr. Mohammed, we would definitely share this video link with all of you. So in an earthquake, seismic is generated as a horizontal force, as we all discussed and agreed. The normal weight is acting down and the seismic on the support is acting on two directions. Now a quick question. This particular support, what you see on your screen, is it a seismic support or a normal support? Okay. Why do you think it is a normal support? Why can't this be considered as a seismic support? Yes, brilliant. So it is a hinge connection. It is a threaded rod dropping. So threaded rod acts like a wire, so it can sway like a swing. This is a seismic rigid support. So you can see it is extremely rigid. It does not allow the pipe to move left or right, front or back. So it is extremely rigid. Also, this is another seismic support with bracings. So again, this is limiting the movement of pipe by bracing it on four directions. This is laterally and this is longitudinally. So on both directions, we are bracing it at designed intervals to arrest the seismic force according to particular building application and so on. This is another example of a multi-layer cable tray converted to a seismic support. Even bigger applications. And this is a snapshot from the calculations what we do. So basically we are calculating the seismic factor. And that brings me to the end of this session. I hope it was useful. I hope we were able to provide some value addition to your day. You spent almost 1 hour with us. Thank you very much for your cooperation. Thank you very much for your participation. Now we will have 10 minutes for questions and answers. I hope you have all shared your questions in the questions tab. Wired bracings can be used for heavy services like chilled water or firefighting system. Mr. Tommy Verghese, yes, wired bracings have been used also for heavy services, but as I said, the wire or the threaded rod has got certain capacity. We need to check the capacity based on how heavy your service is, and more importantly, what is your importance factor of the building, what is the soil type, what is the seismic force. And accordingly, also one important topic which affects the seismic capacity is how far is your service suspended from the ceiling. For example, if you have less than 300 mm suspension, then you don't need a seismic support. But if you have 500 mm, then you need a seismic support. The loads would be different compared to a suspended system which is 2 meters. So here the seismic force would be extremely high. So it depends case by case, but as a rule of thumb, yes, it can be used. We have done firefighting pipe and chill water pipe applications using bracings. Do we need any dampers for vibrating loads? And it has to be protected from seismic disturbances. Yes, there are some applications which has to do with the ductility of the service. So if you have, for example, certain services which are likely to break under the effect of an earthquake or seismic loads, then probably you have to use vibration isolators at those locations wherever it is required. Earthquake resistance shall apply for glass fiber reinforced concrete structures, GFRC buildings. It depends on the specification, to be honest. We have to analyze the specification, and based on that, we have to study and provide you a reply. Okay, we have around 7 minutes left, but I would make sure that you would have all your response to your questions by email. So each one of you will get response to all of these questions. Since we have limited time, I would urge all of you to please visit the poll screen and rate the webinar. You can be as cruel as possible, or you can be as nice as possible, but please rate it based on your real feedback, because we want to use it as a learning curve for our next experience. If you didn't like something, you can be blunt, and you can rate us low. That's okay, because we want to improve our services. Did we from Rahil Wakil? He's asking, did we do we can we use it for false ceiling in buildings? Seismic supports are can be used in false ceilings. It depends on the building specification. Also, it depends on the importance factor of the application. But normally, in this part of the world, the false ceiling is normally considered as less dangerous application, so it is not often considered. But it depends on the specification again. If it calls for it, we can also use it for false ceilings. We can do the design as well. Mr. Ihab has got a question. In most of the structural calculations, two cases always follow. The first is cracked and the second is non-cracked. But I guess for seismic resistance design, is it only a crack concrete, as this will yeah, this is a prerequisite if you want an anchor to be seismic approved. The anchor should withstand tensile zones, which is crack concrete. So only anchors which are working in crack concrete would qualify for seismic approvals. Mr. Suresh has got a question. Is it possible to strengthen seismic resistance after building construction? Yes, absolutely, it is possible. It depends on which application is it. For example, if it is MEP, you can adapt the bracing system and you can make it seismic. Also, if it is structural applications, like if you want to strengthen your building structure for seismic, you can always provide bracings, structural steel bracings, using anchors approved for seismic loads. Mr. Mari, we don't have vibration isolators in our portfolio. So normally we don't provide vibration isolators. We recommend that our customers buy it from outside. We have 4 minutes left. I would still recommend all of you to please take some time to rate us on the poll screen. Mr. Yahya, for firefighting fire sprinkler system, please advise if we can use for all pipe sizes 1 inch to 8 inch used in our project, wire restraint only, and it will be still okay from applicable standard. Mr. Yahya, yes, absolutely, it is applicable as per all standards, especially for firefighting. We are referring to NFPA standards, and as per NFPA, just for your information, you require seismic bracings only for pipe sizes above 2.5 inch, equal or above 2.5 inch, so 65 dia or more. You need to provide seismic supports, and you can very well go for bracing system. Khalid, how does Fisher guarantee the designs? Do the engineers have required certificate? Are the products having required approvals? As we said, all our products are having the seismic approvals. For example, our anchors are tested as per ETAC guidelines, and our steel products are calculated based on the steel nature in the event of seismic forces, and and we provide life expectancy for our designs. And yes, that's it. Mr. Mohammed Shadab, it depends on what application are we referring to. If it is for MEP, then you not only require it at the expansion joints, but at certain intervals calculated. Mohammed Javed Masood, do you have Fisher software available for use with customers to decide and specify anchoring system? If yes, how can it be accessed? Mr. Mohammed, we have state-of-the-art design software called Fisher Experience, wherein you can design for anchor applications under the effect of earthquake. We can definitely send you the link for you to analyze and do the calculation. Also, if you have any questions, please feel free to contact us. We can also support you with the design. Okay, last but not least, I would also mention my email address in the chat screen. So if in case you have any further requirements, you can contact me, and me or one of my teammates would definitely get back to you. And we look forward to meeting you next time. This was a great webinar. We had a lot of participants, and it was a real interactive one. Nobody was sleeping. Everyone was asking a lot of questions. So it was nice. I hope it was useful. We look forward towards seeing you in our next webinar in April. It will be towards end of April, or on 24th or 25th of April. We would definitely keep you posted. Please try to follow us in our social media so that you would not miss any of our webinars. That's it from my side. It's 12 o'clock and it's time for me to leave. Once again, I remind you all to be safe, follow personal hygiene, let us keep virus away, and move forward safely and healthily. Thank you very much.